Force due to radiation. We know that radiation carries energy and momentum. So obviously it will apply a force when it collides with a surface. Okay. So we have to find the force due to this radiation under different circumstances. Okay. So the first case is when the parallel beam of light is falling perpendicularly on the plane surface. So this is a plane surface and a parallel beam of light is falling on the plane surface. Okay. So here we will divide it into 2 or 3 cases. Case 1, if the surface is completely absorbing, that means absorptive coefficient is 1. So it means it is absorbing all the radiations that is falling on it. Okay. And case 2 is if the surface is completely reflecting. So in this case you will say that R is equal to 1. And case 3 is if the surface is both absorbing and reflecting. Okay, we'll look at all these 3 cases together. Now see, first of all, let the intensity be I. Okay, and this intensity remains constant for a parallel beam of light because the area of cross section is constant. Okay, so it remains constant, the intensity remains constant for a parallel beam of light. So the number of photons which is striking the metal plate per unit time is equal to the intensity multiplied by the area. Area has to be actually perpendicular to the flow of light. Now this area is already perpendicular to the flow of light. So number of photons striking the metal plate per unit time is Ia by E. And suppose the wavelength that this light is carrying is lambda, then E can be written as Hc by lambda. So I will write N by T is equal to Ia by E, and that is equal to Ia by Hc by lambda. Okay, so this is the value of N by T. Now change in momentum. Now you know that momentum is means photons carries momentum, right? So you know that photons carries momentum. Okay, so if photon carries momentum, so if there is a change in momentum, there is force. You know that force is equal to change in momentum per unit time, right? So this is the net change in momentum, and the net change in momentum will be what? The total number of photons multiplied by the change in momentum of one photon divided by time. Okay, so that is equal to, force can be written as N by T multiplied by change in momentum of one photon. Okay, now this P stands for momentum here. Sometimes it represents power, P represents power, sometimes pressure. Now here it is momentum. Okay, so don't get confused. So this is momentum. All right, now so the force is N by T multiplied by the change in momentum of one photon. Okay, now we have already seen what is N by T, right? So we have to find out the change in momentum. So case A, when the surface is completely absorbing, in that case you will say that P initial is H by lambda. You know, we have already discussed. So if you have any problem in understanding this, look at my previous video again. Okay, so you will see that the momentum, we have discussed the momentum of a photon, and it is equal to E by C or H by lambda. Okay, you can write it as E by C also, and E can be written as Hc by lambda. So you will get Cc cancel, and you will get momentum is equal to H by lambda, and the final momentum is 0. Why the final momentum is 0? Okay, because it has been absorbed. Now the photon has destroyed. Okay, so you will say that the change in momentum magnitude, only I am writing the magnitude, so the magnitude of the change in momentum is H by lambda. So if the magnitude of the change in momentum is h by lambda, so now the calculating the force is very simple. N by t. Now n by t is I a lambda by hc. Okay, so n by t is I a lambda by hc multiplied by h by lambda. H cancel, lambda cancel, and it comes a simple calculation I a by c. And I multiplied by A is also called the power of the beam, right? So power of the beam divided by C. Okay, so this is the force exerted on the completely absorbing plane surface, okay, by a parallel beam of light. Now, this is the force. If they ask you what is the radiation pressure, what is the radiation pressure? So the radiation pressure will be equal to F by A, and that will be equal to I by C. Okay, so this is the formula for the radiation pressure, and this is the formula for the force, IA by C. Okay, now let us look at the direction. The change in momentum of the photon, clearly if you do final minus initial, final is 0, initial is downwards, right? Initial is downwards, so you will say the final minus initial is upwards. Okay, because see, initial final momentum is 0, initial momentum is minus h by lambda, minus minus becomes plus, that means upwards. So that means on the photons this ground will exert a force upwards. Okay, but on the means on the plate, the photons will exert a force downwards. So I'll write here this force will be, the direction of this force will be downwards on the plate. Okay, you can say direction of this force will be, I'll write it like this, the direction of this force will be along incident light, the direction of this force will be along incident light and perpendicular to the surface. Okay, for completely reflecting surface, that is R is equal to 1. In that case, what will you say? In that case, you will say that R means the change in momentum will be, so h by lambda and then h by lambda reversed. Okay, so the change in momentum this case will be equal to 2h by lambda. So that means the force will be n by t. N by t is how much? Ia upon hc by lambda multiplied by the change in momentum of one photon is 2h by lambda, and that is equal to 2ia by c, and this force is again downwards on the plate. Okay, upwards on the photons due to plate by Newton's third law, and downward on the plate due to photons. Okay, तो photons में force upward लगेगा और plate में force downwards लगेगा, right? And if they ask you pressure, the radiation pressure is equal to force upon area, and that is equal to 2I by C. And the third case is when there is some absorptive coefficient and there is some reflective coefficient also. Okay, the absorptive coefficient and the reflective coefficient together will sum as 1. So I will write it as force will be equal to, so due to absorption, the force will be Ia by C, and only the A fraction, the A is less than 1. Okay, A is less than 1. So this is only the A fraction plus R multiplied by 2Ia by C. Why? Because the force due to reflection is 2Ia by C. Okay, and due to absorption it is Ia by C. So A fraction is Ia by C, R fraction is 2Ia by C. So the net force is A into Ia by C plus R into 2Ia by C. So R can also be written as 1 minus A if they have only given you A. If they have only given you R, then A can be written as 1 minus R. Okay, so So this was the case when a parallel beam of light is falling perpendicularly on a surface. Okay. Now when the parallel beam of light falls obliquely on a plane surface, so this time a parallel beam of light is falling obliquely on a plane surface at an angle theta. Okay, obliquely means at some angle theta. All right, so what will happen in that case? So still it is a parallel beam of light, so the intensity is constant, right? So first of all we will find n by t. Now listen carefully. If you remember the definition of intensity, intensity is defined as, so if you don't remember the definition of intensity, please go back to my previous lecture and refer to the intensity part and then again come back to this lecture, okay? Because this is important, right? Intensity is defined as the energy per unit area per unit time. What is this area? This area is the cross-sectional area. That means this area is the area which is perpendicular to the flow of light. Now the light is propagating in this direction, so if the light is propagating in this direction, that means you have to find this area. Understood? Okay, so n by t will be equal to I multiplied by, listen carefully now, this is the light falling and this is the area, but we need the component of area which is perpendicular to the light beam. Okay, so now if this angle is theta, this is 90 minus theta, this angle is also theta, right? So if this area is A, clearly this area is the component, right? So this is A cos theta. So you will write here I multiplied by A cos theta divided by HC by lambda. So this time the area is not A but A cos theta. Okay, so here A is the area of the plate. Okay, so n by t is Ia cos theta into lambda by HC, right? Now again case 1, if you do case 1, then the surface is completely absorbing. If the surface is completely absorbing, in that case what will you say? If the surface is completely absorbing, then the change in momentum will be equal to h by lambda, but listen carefully, and the direction of this change in momentum, see, initially the h by lambda was in this direction and finally it is 0. So the direction of change in momentum on this plate will be in this direction, okay, because it is along the incident light. So this is the direction of the change in momentum, this along the incident light, okay, on the plate. If they are asking you on the photon, then it will be upwards, okay, and the direction of change in momentum is same as the direction of force, because force is rate of change of momentum. All right, so we have found out the change in momentum due to one photon. You know that the force is n by t multiplied by the change in momentum of one photon. So that will be equal to n by t is Ia cos theta lambda by hc multiplied by h by lambda, and from this you will see that the force comes out to be Ia cos theta by c. Now once you get the force, they'll ask you the pressure. Now finding the pressure is tricky here. Why? The pressure is defined as the component of force which is perpendicular to the surface divided by area. Okay, so the pressure is defined as the component of force which is perpendicular to the surface divided by area. Okay, so everybody write the notes carefully. Okay, sometimes I might say but I will not write here. Okay, so you take your notes carefully. Okay, you every time you should write the notes, right? Now this is the direction of the force, but we actually need this component. Now if this angle is theta, this is also theta, right? So I will write here it is equal to f cos theta divided by the area of the surface, that is A. Okay, so from this you will get Ia cos square theta divided by C divided by A. So from this you will get the pressure is equal to I by C cos square theta. Okay, so pressure is I by C cos square theta. Okay, now I'll write an important note here. Note, sometimes instead of area of plate, area of beam is given. That means what they are saying is, suppose this is the incident light which is falling, and they are saying that suppose small a is the area of the beam. Small a is the area of the beam. Okay, so if this is the area of the beam, if this is the area of the beam and this angle is theta, this is 90 minus theta, this angle is theta, so the area of the surface, this surface will be a multiplied by sec theta, because this is the hypotenuse in this triangle, right? So you'll write the area of the surface as a sec theta. All right, so I'll write it again. The area of the surface is a sec theta. Okay, and what is the number of photons striking this surface per unit time? Because this area of the beam small a is that already perpendicular to the beam, so I'll write directly n by t is equal to I a by e. So I'll write n by t is equal to IA by E, and that is equal to IA. E can be written as hc by lambda. Okay, so now what is the force on this beam, right? So what is the force on this beam? So the force on this beam will be equal to Ia lambda by hc, that is n by t, multiplied by the change in momentum of one photon, because the surface is absorbing. So the change in momentum is h by lambda, and h cancel, lambda lambda cancel, so you will say the force is Ia by c. Okay, then the pressure is, you know that pressure is F perpendicular by A. Now this force is in this direction. Okay, so you will have to take the component of this force. So I'll write F cos theta, because this is the direction of the force and I need this component, and this angle is theta, that means this angle is also theta. So I'll write F cos theta. Okay, F cos theta is the force divided by the area of the surface is A sec theta. So if you put the value of F, you will get pressure is equal to I by C cos square theta. That means what? That means the formula of pressure is same whether they give you the area of the beam or the area of the surface. All right, remember here the pressure is force upon area of surface and not the area of the beam. All right, and in case 2, if the reflective coefficient is 1, so that means the surface is completely reflective. In that case, what change will you see? You will see that the change in momentum is 2h by lambda cos theta, because this component will remain same, there will be no change here, and this component has reversed. That means there is a change of h by lambda cos theta minus h by lambda cos theta, that is 2h by lambda cos theta. All right, so the change in momentum is 2h by lambda cos theta, and it is in downward direction for the surface. Now the force is given by n by t multiplied delta. So you will say that the force is Ia cos theta by hc multiplied by lambda. So this we have already seen what is n by t, and delta p is 2h by lambda cos theta. So from this you will get the force is 2Ia cos square theta by c, and the force is in the downward direction, okay, on the surface. And then what is the radiation pressure? Because the force is downwards, so that is it is already perpendicular to the surface, so I'll write pressure is directly F by A, right? Because force is already perpendicular to the surface. We need the component of force perpendicular to the surface while writing the pressure, right? So I will say that pressure is equal to 2Ia cos square theta by c divided by A, and that is equal to 2I by c cos square theta. Right, now if the area of the beam is given, that is small a is given, so if the area of the beam is given, in that case see, you will write F is equal to I n by t. N by t this time will be I a by e, because if area of the beam is given, in that case area is already perpendicular to the beam or flow of light, right? So in that case you will say that the n by t is I a by e, e is hc by lambda multiplied by the change in momentum of one photon, and that is 2h by lambda cos theta, and that is equal to 2ia cos theta by c. So the pressure will be equal to force by area of the surface. Now if the area of the beam is A, if the area of the beam is A, then the area of the surface is a sec theta. So I will write again, this area of the surface is a sec theta, and you will get 2I by c cos square theta. That means again the formula of pressure does not change even if they have given you the pressure area of the surface or the area of the beam. All right. So the formula of pressure will be 2I by c cos square theta. But yes, the formula of force will depend on the area of the beam or area of the surface. If area of surface is given, it will be 2ia by c cos square theta, and if area of beam is given, it will be 2ia by c cos theta. Now in case 3, if the surface can absorb some fraction and reflect some fraction, so there is absorptive coefficient also and there is reflective coefficient also, but yes, it is a fraction. A plus r is 1. So the absorptive fraction will give a force in this direction, and the reflective fraction will give a force in this direction, and the resultant force will be in this direction. Right? Now the reflective force is, we have already calculated here, the reflective force is 2ia cos square theta by c. So the reflective force is 2ia cos square theta by c. I have not written the value here. You can write it here if you want, multiplied by r, because only r fraction of the light is getting reflected, and the remaining fraction, that is a fraction, is getting absorbed. And for absorption you will write the force due to absorption, that is Fa, and Fa is, we have written here what is Fa. Okay, Fa is Ia cos theta by c. Fa is Ia cos theta by c. Okay, and if you want to find the resultant, you have to take the resultant of these two. Now this angle between this and this is theta, because the incident angle was theta. So if the incident angle is theta, this is nothing but the vertically opposite angle. Okay, so the resultant will be this square plus 2 into this multiplied by cos theta. Okay,